Hey everybody, we're going to continue talking about ionic bonding in this next video lesson, and we're going to specifically talk about how to make ionic molecules or ionic compounds with the elements from the periodic table. In this video lesson, we will first review the concepts from last video, and then I'm going to show you how you can use just the symbols from the periodic table to make molecules that are ionic compounds using metals and nonmetals. First, let's review ionic bonding. First of all, in order for an ionic bond to form, you have to have a metal bonded to a nonmetal. Another thing to think about is that how the bond forms. In order for this to happen, the metal gives its electrons to the nonmetal. When the metal gives its electrons, it becomes positively charged, and when the nonmetal receives electrons, it becomes negatively charged. And then the cation, the metal, is attracted to the anion, which is a nonmetal, because they are opposite charges. Now over here in this space, I'm going to show you something called a dot structure, which shows only the valence electrons of the elements that we're going to be bonding together. And this will hopefully show the ionic bond a little bit more clearly for you. I'm going to use this periodic table here to help illustrate this point. Let's take, for example, lithium. Lithium has one valence electron, so I will write the symbol for lithium over here, Li, and I'll put just one dot for its valence electron. Now over here in green, I'm going to use a different element, maybe a nonmetal. Let's say fluorine. Fluorine has 7 valence electrons. I know that because over the column of fluorine, I see that there's a number 7 written, and so I can identify the metal with 1 valence electron and the nonmetal with 7 valence electrons. Now in the last video lesson, we discussed how metals and nonmetals achieve the octet rule, which means that all elements want to have 8 valence electrons in their outer shell. Now when you're looking at dot structures, a full shell can be represented one of two ways. You can have 8 dots around a symbol, like you will see here shortly. Fluorine only has 7, but it soon will have 8. Or you could represent an element without any dots, which assumes that there used to be dots there, but now since they're gone, what you have is a full inside energy level or full inside shell. So here's what happens with lithium and fluorine. Lithium wants to get rid of its electron, and fluorine wants to receive it. So as soon as lithium gets rid of its electron, you now see that the electron from lithium is gone and shows up here as a red electron over on fluorine. Now lithium is a +1 charge ion and fluorine is a -1 charge ion. And those two ions, oppositely charged, will attract to form the ionic compound LiF. Now due to my limited space, I'm going to erase that stuff underneath the periodic table, but make sure that you keep it in your notes because it's really important. But this happens between lithium and fluorine, but really it could happen between any metal and any nonmetal. Take, for example, calcium, which has 2 valence electrons, and maybe oxygen, which has 6 valence electrons. So I'll draw in oxygen's dots right here. Now calcium, like any other metal, wants to get rid of its electrons, and oxygen, like any nonmetal, wants to receive those electrons. So calcium gets rid of its electrons, as you can see, and transports them, or transfers them, I should say, over to the oxygen. Now calcium, when it loses its electrons, is a +2 charge, and because oxygen gained 2, it's a -2 charge. And now those two can attract one another once again in the compound CaO. And to illustrate my point a little bit further, let's take, for example, a metal with 3 valence electrons like aluminum. Aluminum has 3 valence electrons. And let's take a nonmetal that wants 3 valence electrons like nitrogen. Nitrogen has 5 valence electrons, as you can see, based on its position in the periodic table, and aluminum has 3 based on its position in the periodic table. And once again, the metal wants to get rid of its electrons to the nonmetal. And when it does that, you see that the electrons disappear and show up on the nitrogen. like so. Now because aluminum lost 3 electrons, it's +3. For every electron you lose, you get a +1 charge. So 3 lost electrons, +3. For every electron you gain, it's a -3 charge. And once again, because these are oppositely charged ions, they are attracted to one another and form the compound AlN. Now so far I've showed you examples where the metal and the nonmetal want to lose and gain the exact same amount of electrons, and so they just make a perfect combination. But this ionic bond can form between substances that don't have the exact same number of electrons lost and gained. For example, let's take magnesium, which is a metal, and it has 2 valence electrons, like this. Now let's say, for example, it's in the presence of chlorine, and each chlorine has 7 valence electrons. Again, I know that because of the position those elements are on the periodic table. Now, one magnesium electron can go over and join the chlorine, and that will fill up this chlorine and become a -1 charge. But you see, magnesium still has an extra electron to give away. In order to help magnesium out, more chlorine comes in and says, hey, you still have extra electrons? I'll take your other electron. And when I do that, I'll also be a -1 charge. Now magnesium has lost both of its electrons. Both of those electrons have gone to different elements, 1 to each chlorine. Now magnesium is a +2 charge ion, and each of those chlorines are -1. And when I combine those together, I get MgCl2. Now when we have multiple ions in a compound, then we put a little 2 as a subscript behind the molecule like this. So magnesium and 2 chlorines makes MgCl2. Let's do one more example. This time I'm going to have multiple cations and only one anion. So let's take, for example, sodium and nitrogen. Now these two ions have 1 valence electron for sodium and 5 valence electrons for nitrogen. Again, the periodic table is an incredibly helpful tool in order to come up with the dots. Now that sodium says, hey, I got this extra electron. I need to get rid of it to something. So I'm going to get rid of it to this nitrogen. And so sodium is happy. It becomes a +1 charge ion. Now the sodium is happy, but the nitrogen is not happy because it doesn't have 8 valence electrons. It only has 6 now. It gained one of the electrons from the sodium, but it still has 2 more spots where it could receive electrons. And so the sodium says, hey, let me go find a friend. Because if there's one sodium atom, there's probably another sodium atom. And so sodium says, let me find a friend and see if I can get them to give you an electron. Nitrogen says, hey, that's awesome. Thanks so much. I'll take anything you can give me. And so you get a transfer of an electron from a sodium. So now this sodium is also +1 charge. And finally, there's one more spot for one more electron, so sodium says, let me find a third friend and see if we can figure out a way to get nitrogen happy. So sodium says, all right, here, take this electron. I'm going to transfer it to you, so now that you have a full valence energy level. So each sodium donated 1 electron to the nitrogen. The nitrogen received 3 electrons, so it's now a +3 charge. And if you've got 3 sodiums and 1 nitrogen, well then the molecule is Na3N. Notice that when we write out the formula, we lose the charges of the ions because as soon as they come together, the charges cancel each other out. The 3 positives cancel out the 3 negatives, and you get just this compound, Na3N. The whole goal of this last little bit of this conversation, showing all the ions and the movement of the electrons from the metal to the nonmetal, was just there to show you how it happens. But in reality, we don't really need to show all those steps. What we really need to worry about is the ion charges. We can skip right to the ion charges because we have those written over the top of our periodic tables as well. So on a quiz or test, I'm not going to test your ability to draw pictures, but I am going to test your ability to think this through and make sure that the charges of the cations and the charges of the anions always balance each other out. they always have to cancel one another. So here's what I would expect you to know how to do. If I give you lithium and just say you've got lithium and it's a +1 charge ion, and you've got sulfur, which is a -2 ion, what would the compound be over here that would be created from the combination of lithium and sulfur? Now you know that lithium is a +1 charge because lithium's in the first column and it's +1 charge. And sulfur is a -2 charge ion because of its position on the periodic table. Now as they combine, if you take one of each of them, you're going to have leftover sulfur charges because a +1 charge will only cancel out one of the sulfur's two charges. So because of that, you need to think to yourself, okay, how do I cancel out these charges by adding more lithium to the mix? If I add another lithium, now I have two positives. As you can see, if I total this up, it's +2 charges here, and then the sulfur charges are -2, and since they're equal but opposite, they'll cancel each other out. Now simply just count up your ions and combine them to make a molecule. Li2S is the name or formula of this compound between lithium and sulfur. In review, I figured out the charges by its position on the periodic table, and then I looked at the positives and negatives, and I added positives to cancel out negatives, or add negatives to cancel out the positives until you get the same but opposite so that they can cancel each other out, and then as a result, you get the final product. Let's try another one. This time I'm going to combine calcium and fluorine. Now looking at these ions, I notice I don't have any charges, but I can figure it out based on its position on the table. Calcium is a +2 charge, so let's draw that in there. And fluorine over here is a -1 charge. And since they are opposites but not equal, I'm going to have to add either more positives or more negatives in order to balance these charges or cancel out the charges. So adding more positives would actually get me more positive. +2, I add another calcium, +2, so that'd be +4. That's not actually catching up. I need the pluses and the minuses to be equal but opposite of one another, opposite charge. In order to cancel out the charges, I need to add more fluorine into the mix. Because as it sits right now, calcium's a +2, fluorine's a -1, so you have leftover +1 charge. So let's put in another element that has a -1 charge, so another fluorine, and now I have overall -2 charge. If I add -1 and -1 together, I get -2. And if I add +2 to nothing, then I have +2. And now I have opposites and equal, and so you have the formula CaF2 as a result. So I'm going to put these three on the page, and I want you to pause the video and see if you can figure out what the formula would be for each of these three. Then go ahead and play the video and I'll work the answers for each one. Now let's get started. With my periodic table in hand, I don't have it on this page, but I can make it available. I know that the charges of the potassium and the oxygen are +1 and -2 respectively. So now that I have more negative charges than positive charges, I need to add another potassium +1 to this mix, resulting in +2 overall and -2 overall, and those can cancel out. So I have, as a result, K2O. That is the compound from potassium and oxygen. Now let's move on to number 2. From the periodic table, I know aluminum is a +3 charge ion, and I know bromine, a halogen, is a -1 charge ion. And so I have more pluses than minuses, as you can see, and so I need to this time add more negative charges. Now adding one more bromine would help a little bit. Now I have a +3 charge and 2 -1 charges, but that's still not equal. And so I need to add one more bromine to the mix in order to get a -3 total, and aluminum has a +3 total. Now I have equal but opposite, and the formula for aluminum and bromine is AlBr3. Finally, I have barium and sulfur. And barium has a +2 charge because it's in the same column as magnesium and calcium. And sulfur has a -2 charge. Now since I have +2 and -2, I don't need to add any more pluses or any more minuses. These have already been canceled out. Because of the way they're written, they come already balanced. So I simply just need to put BA and S together as BAS. Well, that takes care of this video lesson. Thanks for watching.